In this video, we will continue on with our writing chemical equations topic, and I'm going to teach you the skill of balancing equations. So if you could open your booklet at page 13, we're going to be working from there. So in our last lesson, we were having a look at word equations and how they can be used to represent essentially the story of a reaction. They involve the reactants, the things that we react together, and they tell us what the products are, the things that are made. And balance symbol equations, they are a more convenient way of representing chemical reactions. However, they're slightly more tricky to write. But what we need to remember with balance symbol equations is that the equations need to be, as the name suggests, balanced, because no atoms are lost or gained during a chemical reaction. The atoms are just rearranged. It's a bit like in physics where energy is neither created nor destroyed. It's just converted to a different form. And so we must make sure that in our balance symbol equations, there's the same number of atoms on the left-hand side of the equation as on the right-hand side of the equation. Let me give you a quick example. So let's start with a word equation, and that's where we normally do start when writing balance symbol equations. Here's the reaction between magnesium and oxygen. And as we said in our last lesson, those are our reactants, the things that react together. We've got an arrow that then essentially means reacts together to give. And on the right-hand side, we write our products. So magnesium and oxygen react together to give magnesium oxide. There's just one product in this reaction. So when we talk about left-hand side of the equation, we're talking about left-hand side of the arrow. We don't normally draw that in, but I'm just showing that to represent. So everything on the left of the arrow is what we call the left-hand side of the equation. And then everything on the right-hand side of the arrow is the right-hand side of the equation. So the left-hand side are our reactants, right-hand side are our products. So word equations are good for representing what happens in a reaction, but balance symbol equations are actually more convenient way of writing it. They're a shorter way of writing it, and also gives us an idea of the number of atoms involved, and we can actually do a lot of calculations based on a balance symbol equation. Now, what we're going to do in this video and at this stage is just practice the skill of balancing. But I'm going to show you briefly how you would convert this into a symbol equation first of all. So essentially we take each of our reactants and our products and we convert them to formula. So magnesium has the symbol Mg and then our plus sign. We react that with oxygen. Oxygen's diatomic, so we have to write it as O2. And then magnesium oxide, well, we would need to do our swap and drop for that. Magnesium is Mg with a valency of 2 because it's in group 2. Oxide is just oxygen, which is in group 6, so has a valency of 2. Those actually then cancel out to 1 to 1. When you swap and drop them, then you would get MgO. Now, I know that was very fast, and don't worry about that at this stage, but it's really just using our work from formula to convert the word equation into this symbol equation. But there's a problem with this equation. We don't have the same number of atoms on the left-hand side as we do on the right-hand side. So one thing we'll do when we practice these balancing of equations is we'll make a list on either side of the equation to essentially count up how many of each type of atom that we have. So let's see, magnesium. On the left-hand side, we have 1, if you look at it here. Oxygen, on the left-hand side, we have 2. On the right-hand side then, magnesium, there's no number after it, so we have 1. And oxygens, again, there's no number after it, so we have just 1. So this equation is not balanced because it doesn't have the same number of atoms on either side of the equation. We have 1 more oxygen on the left than we do on the right, and that just doesn't happen. We can't just lose an oxygen atom. So what we do is something called balancing, and how we do that is we put big numbers in front of the individual formula. Okay, so you can see on the right hand side I need 2 oxygens, but I only have 1 at the minute. So what I think to myself is, what number do I need to put in front of that whole formula to make it 2, and that number will multiply. So what I do is I put a 2 in front of the MgO. What that does is it affects everything in that formula. So we have affected my magnesium and the oxygen. There's now 2 magnesiums and there's 2 oxygens, because it's 2 times 1 magnesium is 2 and 2 times 1 oxygen is 2. So I fixed the problem with the oxygen, but I've actually made a problem with my magnesium. So I've got to solve that now. I need 2 magnesiums on the left, and again I can only fix that by putting big numbers in front of the formula. And so I need 2 magnesiums in the left, so I put a big 2 in front of the magnesium, and that means I then have 2 magnesiums there. It's really important that you do it this way. Sometimes people are just tempted to put a wee 2 in here and think that that solves the problem, but it doesn't. We can only balance by putting big numbers in front of the whole formula, and I'm going to show you a way to help you remember that. But that's essentially the process of balancing an equation. It's essentially making sure that you have the same number of each type of atom on both the left hand side and the right hand side of the equation. So let's go back to page 13. Here what you have is a method of balancing an equation. You do not need to learn this method off by heart. You would never be asked to write it in an exam, but it's there as a guide for you as we practice this skill. So if you're not sure what to do next, go back to this method, and the first few examples that you try, follow this method step by step. And what will happen is that we'll do so much practice of this that you'll just then know this method off by heart, in the sense that you'll have practiced it so many times, but it must be done step by step. So let me just take you really quickly through this method, and then we'll look at some examples. It's easier to kind of learn it through an example. So what we do on the left hand side is we make a list of all the elements present, ensuring that all the elements are separated out. We copy this list in the same order. It's just so much easier to do it if you do it in the same order under the right hand side of the equation. Count up how many of each type of atom there is on the left hand side of the equation, and count how many of each atom there is on the right hand side of the equation. Then, and this is the part to make you remember that we can only put numbers in front of the formula, we draw a box in front of each formula, and we'll show that in an example. We balance by placing a number in one of the boxes in front of the formula. These balancing numbers have the effect of multiplying everything in the formula by that balancing number. So you're thinking, what do I need to multiply this by to get the number of atoms that I need? Number 7, after each balancing number is placed in one box, update the list to keep track of how many atoms you have on either side of the equation. Number 8, repeat steps 6 and 7, so that's putting numbers in boxes and updating your list until the lists on either side of the equations match, i.e. there are equal numbers of each type of atom on either side of the equation. And then number 9, rewrite the equation without the boxes. And sometimes this can involve putting one number in front of a formula and then having to change it. That's just some of the more complicated balancing numbers, balancing equations. We have to do that. But again, do it step by step. And the key is update as you go. Keep a track of how many atoms you have as you go along. So let's go over the page and have a look at worked example 1, and we'll practice this method in the same order, step by step, in order for you to see this in practice. So step number 1 is to make a list of the elements that you have on the left hand side, ensuring that they're all separated out. So the first element we have is zinc, and so let's write that in our list, Zn, just its symbol is fine. If we move then across to the right, we can see that the next element we have is hydrogen. The next element we have is chlorine. Now, sometimes depending on the font, it can be difficult to tell, is this chlorine or is it carbon and iodine? But this is chlorine in this example. So you can see how on the left hand side of the equation, hydrogen and chlorine are together, but we need to separate out all the elements. And the trick for trying to do this is look for a capital letter. A capital letter is the start of a new element, and you must then separate them out. So you can't count hydrogen and chlorine together because you'll see they're not together on the right hand side, so we wouldn't be able to do it that way. So step number 2 then is to copy this list in the same order on the right hand side. So simply on the right hand side of the equation, I write Zn, H and Cl. And writing this list under the relevant side of the equation allows me to remember which side I'm referring to. The next step, step number 3, is to count how many atoms you have on the left hand side of the equation. So you can see zinc, let's take it just each in turn. Zinc, I have 1. Hydrogen, there's 1. And chlorine, there is 1, because none of these symbols have any numbers after them. Then step number 4 is to count up how many atoms you have on the right hand side of the equation. Start with zinc. There's no number after Zn, so there's just 1. The next element we have in our list is hydrogen, so we'll go over and count it, and we can see we've got 2 hydrogens. And then chlorines, it's Cl2, so there's 2 chlorines as well. And you can see that keeping the list of elements in the same order on either side of the equation allows us to compare easily which elements are balanced and which are not. So if we look at zinc, we can see there's 1 on either side of the equation. So we'd say our zinc is balanced. We have the same number of zincs on either side of the equation. But if we look at hydrogen, we've got different number of hydrogen atoms on either side of the equation. We've got different number of chlorine atoms on either side of the equation. So we've got to fix that. Step number 5 then is to draw a box in front of each formula. And this is not an essential step, but it reminds us that we can only balance an equation by putting numbers in front of the formula. I can't just stick a little 2 in here. Don't do this, but I can't just stick a 2 in there to give me 2 chlorines, because what that does is it changes the formula of our reactant or product, and that's incorrect. Because what we've done is maybe swap and drop to get the formula. We can't change the number of atoms in the formula themselves, but we can change how many molecules of each substance that we need, and we'll see that in a wee second. So what we want to do is draw a box in front of each formula. So my first formula is zinc, so I would put a box in front of there. My next formula is then separated by a plus sign. So my next formula is HCl. So basically, each formula is separated by a plus or an arrow. Okay, and that's the start of a new formula. So there's no other formulas on the left-hand side of the equation. So we go over to the right-hand side of the equation, and our next formula is ZnCl2. So we put a box in front of that. That's then separated from our next product by a plus sign, and so we need to put a box in front of our H2. So put boxes in front of each of the formulas. Now we start the process of balancing by putting numbers in these boxes. And what we need to remember is that any number we put in these boxes has the effect of multiplying everything in that formula by the number that we put in the box. Okay, so what the best way to do this is pick one of your elements that's not balanced and try to fix that. Don't try and solve the whole problem in one go, because sometimes it will take a few steps to get there. So pick one element that needs balanced, try to balance that, update your list, and then go from there. Don't try to solve the whole problem in one go. Okay. So the first element I can see that's not balanced is hydrogen. So I think to myself, how can I balance that hydrogen? I've got 2 on the right, but only 1 on the left. How do I get 2 on the left? So how do I get 2 on the left? How I do that is I put a 2 in front of the HCl, because what that will do is it will multiply everything in that formula by 2, giving me 2 hydrogens. So what I do at this stage, and this is on to our next step, step number 7, is to update our list. We've got to keep a track of how many atoms we have. So you can see that that 2 is going to affect hydrogen and it's going to affect chlorine. It doesn't affect zinc because there's no zinc within that given formula that the box is in front of and that we've put the 2 in front of. So let's think, how many hydrogens do we now have? Well, we have 2 times by 1, which is 2. And how many chlorines do we have? We have 2 multiplied by 1, which is 2. So you've got to remember that that number affects everything in the formula. Okay, so look at our list now, and actually what you can see is that putting a 2 in front of our HCl has actually balanced our equation entirely. The next step is to keep repeating this process until our lists match, essentially until we have the same number of atoms on both sides of the equation. And we can see that we now do. We have the same number of atoms on the left-hand side as we do on the right-hand side. So I don't need to go any further in terms of my balancing, but the last thing to do is then just to write out the equation again, but without the boxes in front of them. And again, you might have done a bit of changing of the numbers, so it's really just to get this nice and neat. So I've no number in front of my zinc, so I just write Zn plus, and then I write 2HCl, so just removing the boxes, not the numbers in the boxes. Then my arrow, I have no number in front of zinc chloride, so it's just ZnCl2. No number in front of my hydrogen, so it's just H2. And that's the equation, now balanced. So let's move on to worked example 2. And I'd like to challenge you to try this yourself. So to pause the video and try it yourself before then playing the video to check if you're correct. And you can even, if you've tried it yourself, you can scroll on and see if you've got the right answer. A good way, obviously, to check and see have you done it correctly is if your lists match. That doesn't necessarily mean you've done it right though, so you do need to check through that you've got the correct answer. So if you feel confident enough, please pause the video and try this for yourself. If you'd like me to take you through one more example, that's absolutely fine. Just continue watching on, but if you want to try it yourself, please pause now, give it a go, and then check your answer with the video. Okay, so I'm going to take you through either to check your answer if you've tried it yourself, or if you just need another example to go through, that's absolutely fine. Sometimes it's helpful to just watch the working out and then to write it in afterwards. So our first step is to make the list of our elements on the left hand side. So we've got nitrogen and we've got chlorine. We'll make the list on the right hand side as well. Again, we have nitrogen and chlorine. Keeping those in the same order will help with seeing which elements are balanced and which are not. The next step is to count up the number of atoms of each element on the left hand side. So with nitrogen there's no number after it, so we put a 1 there. With chlorine there's a 3 after it, so there's 3 chlorine atoms. Let's go over to the right hand side now. How many nitrogens do we have? We have 2. How many chlorines do we have? We have 2. So you can see that this equation is not balanced. We do not have the same number of each type of atom on either side of the equation. So next step is to put our boxes in front of the formulas. So we put a box in front of our NCl3, then we've got our arrow. Our first product is nitrogen, N2, our second product is chlorine. So we put a box in front of each formula, each reactant or product. So where do we start with this? Because our nitrogen and our chlorine are not balanced. Well, there's 2 ways of thinking. You can start with either element, it doesn't matter. You will eventually get there, but one way might take a little bit longer than the other. What I would say in terms of tips is leave the things that are on their own to the end, because they're the easiest to fix. So what I mean is essentially the right hand side here, we've got nitrogen and chlorine on their own. So any number I put in those boxes, it will only affect that element. Whereas if I put a number in this first box on the left hand side, that's going to affect nitrogen and chlorine. So if I need to put a number in that box, it's probably best to do that first. The other thing to look at is, well, your numbers. So nitrogen is 1 on the left and 2 on the right. That's probably a little bit easier to fix than the fact that chlorine is 3 on the left and 2 on the right. That's maybe not as easy to fix, and we can't fix it with just one number. So let's start with our nitrogen. How do we balance it? Well, we need 2 on the left hand side, so I'm going to need to put a 2 in this first box. That's going to affect nitrogen and chlorine. I would always put the lines through the numbers that it'll affect, to make sure that I update my chlorines and not just my nitrogens in this example. So how many nitrogens do we have? It's 2 times 1, which is 2. How many chlorines do we now have? It's 2 times 3, which is 6. Okay, so my nitrogens are now balanced, but my chlorines are not. So what do I need to do to balance my chlorines? Well, I have 6 on the left and 2 on the right. So I'm asking myself, what number do I need to put in this last box to get 6 chlorines? So what number will multiply by 2 to give me 6? Well, that's going to be 3, because that's now 3 times by 2 which is 6. So again, I'm updating my list as I go along. Now you can see that the lists match. I have the same number of nitrogens and chlorines on both sides of the equation. So the last step then is just to rewrite the equation without the boxes. So your final equation is, and that's a big 2, NCl, and then a tiny 3 down at the bottom, arrow N2 plus big 3, Cl2. So make sure that you have that equation written in and written in exactly as it is with the numbers the correct size. So your balancing numbers, as we call them, the 2 and the 3, those are big numbers, normal, same size as your letters, but the numbers is part of the formula. So these would be 3s and 2s, they are subscript, so they are smaller numbers and at the bottom. And then finally at this stage, and then we'll pause it here and do some more examples in our lesson on Monday, and we'll try worked example 3. So again, and especially if you didn't in worked example 2, please try and pause the video, try this for yourself, and then play the video to check it. What I would say to you is be careful with this one, because you'll see that oxygen and hydrogen appear multiple times even on one side of the equation. So when you're counting up your atoms at the start, let me take you through oxygen. Well, there's 1 here plus 4 here, so that's going to be 5 oxygens on the left hand side. So make sure you check to see if that element appears again. And then just to say, if you then put a number in front of one of these formulas, so say I put a 2 in front of here, don't put that in because that will not be the right answer. That only multiplies this formula by 2, so you need to almost count up again from scratch. So again, if we were to do oxygen, we've got 1 here plus 2 times 4, which is 8, which is 9. So we don't double the total number of oxygens, we only double the number of oxygens in this formula, and then still need to add on the number of oxygens in this formula. So hope that makes sense. Don't just assume that you multiply the whole number by your balancing number. So give this one a go, pause the video now. This one might be a little bit trickier because of that appearance of the element a couple of times, even on one side of the equation. But just keep a careful track of your balancing numbers and how many atoms that you have, and take it step by step, only putting one balancing number in at a time and updating your list each and every time. So pause the video, try it, and then please make sure you play the video again and check that your answer is correct. Okay, so you should have had a go at this by now, but let me take you through the whole working out of this example. So first of all, we make the list of our elements. So we've got sodium, Na, oxygen, O, hydrogen, H. Then we go over to the next formula and we've got hydrogen again, but we're going to total up the hydrogen, so we don't write that again. Then we've got sulfur, and then we've got oxygen, but we've already got that in our list, so we don't rewrite it. Then over on the right hand side, we write that list again in the same order. Even though the elements might not appear in the same order on the right hand side, that's okay. Just keep your lists the same because it allows us to directly compare how many of each type of atom we have. So counting up carefully now, sodiums, we've just got 1 on the left hand side. Oxygens then, we've got 1 here plus 4 here, which is 5. Hydrogens, we've got 1 here plus 2 here, which is 3. And sulfur, we've got 1. On the right hand side, we have 2 sodiums. Then we have 4 oxygens plus 1 here, which is 5. Hydrogens, we have 2 here. And sulfurs, we have 1 here. So if I look at my list, at the minute it appears that sodium is not balanced and hydrogen is not balanced. So I'm going to need to put my boxes in front. I will need to balance this. So remember, the boxes aren't essential, but they do remind us that we can only put numbers in front of the formula. We can't change the actual formula, and we can't put little small numbers in to change the formula. So looking at that list, I'm comparing sodium and hydrogen, and I think to myself, well, sodium's going to be a little bit easier to balance because it's a ratio of 1 to 2 at the minute, so that's probably going to be easier to balance than hydrogen is. Okay, so how are we going to get 2 sodiums on the left hand side? We're going to put a 2 in this box here, but that's going to affect sodium, oxygen and hydrogen. So I'm going to put a line through sodium, oxygen and hydrogen to remind myself that I need to recount up each of these. So how many sodiums do I now have? I have 2 times 1, which is 2. How many oxygens do I now have? Now remember, this 2 only applies to this formula that I've put the number in front of. So it's not like I double the number of oxygens. It's not like I have 10 oxygens now. Think what we have in this formula this is sodium hydroxide. We have 2 times by 1, which is 2 here. Plus I have my 4 here, and I haven't added any number in front of that sulfuric acid, so it's just 2 plus 4, which is 6. So just be really careful with that when elements appear more than once on a given side of the equation, that you only affect the number in that particular formula by putting a number in the box. You don't affect the whole side of the equation. Same with hydrogen, we need to be careful. So again, we've got our 2 multiplied by 1 here, which is 2. And then we have 2 on the in the sulfuric acid. So that's 2 plus 2, which is 4. And I haven't affected my sulfurs. So just be really careful when you're counting up your number of atoms after you've put a number in one of the boxes. Just make sure you do that again, step by step. You're essentially adding up your number of atoms from scratch again. Okay, let's have a look at our list now. So we can see that sulfur's still fine, sodium is now balanced, but now oxygen isn't balanced and hydrogen is still not balanced. So again, look at your numbers there. With oxygen, we've got 6 to 5. That sounds like a hard one to fix. Hydrogen is 4 to 2. That sounds like an easier one to fix. So if we look at our right hand side, hydrogen appears in water, H2O. So what I need to do is think of a number to put in this box to make it so that I have 4 hydrogens. So essentially I'm thinking, what number multiplies by 2, because there's a 2 in this formula, to give me 4 hydrogens. And that is, of course, the number 2. So that's going to affect hydrogen and oxygen, because there's oxygen in that formula again. So how many hydrogens do I have? I have 2 times 2, which is 4. And how many oxygens do I have? Well, remember, we don't just double the number of oxygens altogether. We think, okay, now I have 2 times by 1 here. So there's 2 in this formula. And how many do I have in the other formula? I have 4. And I add those together, 4 plus 2 is 6. So I don't double the number of hydrogens overall because I didn't put a number in this box. So I haven't increased my number of oxygens in that sodium sulfate. I've only increased the number of oxygens from the water because I now have 2 water molecules rather than 1. And if we check our list now, you can see that the lists match. And so therefore, all I need to do is rewrite the equation. And when I do that at the end, I do that without boxes and just to make sure it's nice and neat as well, and that stands out at the end. And so there you have it. That's the process of balancing an equation. And in order to write a balanced symbol equation from the description of a reaction or from a word equation, all we need to do then after this is to put together changing from a name to a formula, which we did at the start of this topic, and then this process of balancing an equation. So it's then putting the 2 skills that we've learned together and writing a balanced symbol equation out of that. So on Monday we'll do a little bit more practice of this. You can stop there for now, you don't need to do any further practice. Monday we'll bring this together and see if there's any questions on this, so please make sure if you don't understand this, then please make a note of any questions you have and you can ask them in our lessons on Monday. If you'd like a little bit more practice in that, then I would suggest maybe even trying those examples that we have just worked through, write them out on a spare piece of paper and try them again from scratch and see if you can work through that process and get the correct answer. Thank you.